Hi everyone, today we are going to talk about majority element appearing more than n by 2 times. So the question is like we are given an array and what is the length? 0, 1, 2, 3, 4, 5, 6. Sorry, it is 2 and 2. So 0, 1, 2, 3, 4, 5, 6. And so length is equals to 7. Okay. We are given an array of length 7 and we have to find an element which is appearing more than n by 2 times, that is 7 by 2, which is equals to 3 times, more than 3 times. So clearly by seeing we can see by observation we can see that it is 2 2 2 2 2 is appearing 4 times, that is greater than 3. Okay, and 3 is appearing 2 times and 1 is appearing 2 times. Okay. What we will use an algorithm known as Moore's voting algorithm, or it is mostly used for this kind of questions, majority element and greater than n by 2, n by 3, n by 4, such kind of questions. So how we will solve it? First solution is the simple brute force way. We will use one array we will use 2 pointers and using nested for loops. Like this will point I, and for each I we will check j, and for each I and j we will increase count, and if count is more than n by 3 times we will return the index element. For example, here it will be 2, and but its time complexity will be clearly greater than n linear time. It will be greater than linear time, it would be n square times. So what would be a much optimal way? And another example, another way should be using hashing. Okay, and in hashing we will store each number with key value, and each when the number stored is like we have a map. Okay, like we have a map 2 and its current value is 1, means its occurrence is 1, frequency is 1. Now again here it comes 2, now we will increase its frequency by 2. Now 3 is here is 1. Now again we will see 3 is appearing, we will change its frequency by 2. Now 1 is appearing once, now again 2 is now 3, again 2, now its frequency is 4. So clearly we will find the max frequency of the element and we will return that element or the key. But here we will have time complexity equals to big O of n and space complexity of big O of n. Why? Because of this map. Okay, because we are using an extra variable, extra map for storing and then finding the answer. Okay, then what can be another optimal way? The most optimal way is Moore's voting algorithm. What does this algorithm say? This algorithm say that we have this array, let's write its index 0 1 2 3 4 5 and 6. Okay, now we will have our counter variable. We will define counter variable with with 0, and an element should be like a minimum val of integer dot minimum val, because right now element is nothing. Okay, we will start from here. Now we will check at each element. Okay, when the counter gets 0 we will increase it by 1. Here at starting counter is 0, yeah, counter is 0. Now we will increase the counter by 1 and our element will be 2. Our element is updated by 2, that is array of I. Now we will traverse I plus 1. Now second traversal I is here. Now I comes here. Now I comes here. Now again, if the element is equal to if the array of I is equal to this element is 2. Okay, so array of I is equals to 2, yeah, it's equal. So again we will increase the counter by 2 and again I plus plus. Now array of I is 3 is equals to 2, no. So again what we will do, we will decrease the counter by 1. The counter here is 1 and element is 2 only, because when the counter becomes 0 then we will update the element with the current array of I element. Okay, so here element is 2 still. Now again I comes here, so now counter becomes 0. Now the counter becomes 0. Now what happened? The counter here is 0 Now next time when we iterate, sorry, here counter is updated 0. Now next time I is updated to 4. Now element of 4 is 4 and counter is also 4, so we will change the counter by 1. Here is counter 1, counter equals to 1, and element is equals to 1, because array of 4 is 1. Yeah. Now we will move to the next element. Here what we see, that counter is equals to array of I is not equals to counter, array of I is not equals to element, array of 5 is 2, 2 is not equals to 1, so counter minus minus counter equals to 0. Now array of I plus plus, array of 5 plus plus, so now counter is equals to 0, counter equals to 1, and element equals to 2. Now the last element when counter is not equals to 0 is 2, so 2 is our element. Okay, so now let's verify for it. For verification we will use another variable. Let's name the variable be v equals to 0, and again for each iteration we will increase v when element is equals to array of I. Okay, so for I equals to 0, element is equals to, yes, so v equals to 1. Now array of I 1, same, yeah, so v equals to 2. Now we will check for this only, because we have found that element is equals to 2 is the majority element, so we will check for only 2. So we will not increase or decrease the v variable when it's not equals to 2. We will increase only the we will only increase the variable when it is equals to 2, and we will not decrease whenever it is not equals to 2. Okay, so now here 3, so 3 is not equals to 2, so simply we will increase the I again. 3 is not equals, now again I is not equal to 2, again, yeah, I is equals to 2, array of I equals to 2, so counter equals to 3, again array of I plus plus I equals to 2, yeah, so counter equals to 4. Now check, v is greater than n by 2, 4 is greater than 7 by 2, yeah, clearly 4 is greater than 3, so we will return this element. Okay, so that's the answer, and the code will be in the description below.